All right, good morning, Calculus 2. Let's do another integration by parts problem. This is a good one. This is sometimes known as my nemesis. No, I think I can do it. There's some interesting things happen here. So this is an integral of a secant cubed x dx, okay? And so it's a trig integral, of course, but we're going to use integration by parts and something interesting happens. So let's learn how to do this. If I'm going to do integration by parts, I have to call something u and I have to call something dv. That's how integration by parts works. So the original integral is a u dv. So you call something u and you call something dv. And I haven't given you a whole lot of guidance there. After you experience a bunch of problems, you kind of learn what to do. But whatever dv is, you have to integrate. So you have to pick something that's easy to integrate. Often the e function or the sine or the cosine is often what you do. When there's a log involved, you can't integrate a log, so you don't let it be the dv. You tend to let it be the u. So there's some different aspects going on. But I want something that's easy to integrate out of this secant cubed. And so I'm going to split it up and think of it as a secant times a secant squared. And secant squared is going to be my dv because secant squared is so easy to integrate. Because the derivative of tangent is secant squared, so the integral of secant squared is tangent. So that's the strategy. I want dv to be secant squared. Well, if dv is secant squared dx, that leaves the u to be a secant. All right, I need to integrate. Integrate the dv to get v gives me a tangent x. Taking the derivative of secant to get du gives me a secant x tangent x. All right, there's the first set of integration by parts. And so here's the answer. According to integration by parts, you do this integral u dv, and then the answer is uv, u times v, secant x tangent x, minus another integral. There's always another integral to do. v du. v du will be a v times du. That'll be a secant x tangent squared x. This is multiplied together here. A secant x tangent squared x. Yeah, right. Okay. So now I got to do this integral. And I remember an identity. Some identities are going to be useful in this chapter. And one of them is tangent squared plus 1 is secant squared. So that's an identity I have memorized. You should memorize it. It's useful, like I said, occasionally, especially a little later in this chapter, but it's useful right here. And, you know, when you memorize this identity, tangent squared plus 1 is secant squared, there's another, you can manipulate it. You can move the 1 over, and tangent squared is secant squared minus 1. And that's what I need to use, actually, right here. I'm going to change this tangent squared into a secant squared minus 1. So this tangent squared this is multiplied by a secant squared minus 1. I'm substituting that in there. Well, there's a minus sign out front. There's also this term out front, so try to stay kind of organized. Here, I'm going to move down here, move this equal sign down here, and I have the secant x tangent x minus this integral, which is now, when I distribute this, it's an integral of a secant cubed. Yeah, interesting. The original integral I was working on just showed up. That's interesting. But hang on, what do I have? I'm distributing secant cubed and then a negative secant. If I take this negative sign with me, it'll be a positive, and I'm going to think of it as a separate integral over here, secant x dx. Probably a dx here. All right, so you with me? I distributed. It's a secant cubed minus a secant cubed minus a secant. This minus sign made this integral negative, but it made that integral positive. And it's two separate integrals. And I know how to do secant x. It's pretty obscure. It came from the end of chapter 5. It was just a memorized thing. There is a little method behind it, but I would just memorize it. It is the natural log of secant x plus tangent x. So we just integrated that. The integral of secant x is this memorized thing at the end of Cal 1, Chapter 5, we learned that. All right, well then here I am. I was trying to do the integral of secant cubed, and in the process, the integral of secant cubed shows back up. That is interesting. And the way to deal with it is this. This is interesting too. So there's an equation here. What's on the other side of this equal sign is the original integral secant cubed. And then this secant cubed shows up on this side of the equation. So what I want to do is add one of these integrals of secant cubed to both sides of this equation. Adding it to this side of the equation will cancel it. Adding it to this side of the equation will give me two of these integrals, secant cubed. Secant cubed x dx. The integral I started with showed back up in the problem. I treat it like an equation. I add that integral to both sides of the equation. Here it cancels. Over here it now gives me two of these integrals. And what's the answer? Two of these integrals equals this, secant x tangent x, plus this term here, natural log secant x plus tangent x. And this term got added to the other side, so there's two of these integrals. Now, if I want the answer to this integral, I bet you can tell me what to do. Divide by 2, or multiply by a half, however you want to say it. So the answer to this original integral, it feels like I've got the answer without ever really doing it. I multiply by a half, and I get 1/2 secant x tangent x plus 1/2 natural log of secant x plus tangent x. We are at the end. I think now I'll put a plus c, and that's the answer to secant cubed. Pretty famous integral. And the process, I think, is interesting. The original integral shows back up in the process. You stop. You don't keep trying to do it. You add it to the other side and join it with the original integral, and you solve for it that way. That happens in a problem like this. I don't think I'm going to do this one right now, but in a problem like this, e to the negative 2x cosine x dx. That's a classic integration by parts problem where the original integral shows back up in the problem. So maybe you let u equal the e or the cosine, either one, but stay consistent. When you do the next iteration of integration by parts, let u be whatever you did the first time, and you'll see the original integral show back up in the answer. Somehow you add it to the other side. It might not be 1, maybe it'll be 3/5 of those integrals. You add 3/5 of those integrals to the other side. You get 8/5 of those integrals. You divide by 8/5. So I'm previewing how to do that. It's a good one. I like that problem. There's a couple of them in the book maybe. All right. Thank you very much. Good luck. Do some homework.